Hey, it's Nueve, number 9 lecture video on chemical bonding, electronegativity differences and bonding. So electronegativity is a very important vocabulary term and concept. It has to do with the pull of the nucleus of one atom for the electrons in the valence shell of another. So we used effective nuclear charge to describe how electronegativity patterns worked. And what this all becomes in this lecture is if you look at the electronegativity numbers for each element on the Pauling scale, and you find the difference between two elements that are supposedly bonded together, the difference can help us figure out if that bond is going to be ionic, polar covalent, or nonpolar covalent. And then you can stop remembering all the silly little shortcuts and just start knowing your rules about figuring out bond character and molecule character. So here we go, electronegativity and bonding. Well, ionic bonds are forces of attraction between oppositely charged ions. One's a metal and one's a nonmetal. That's just the basics of what an ionic bond is. Formation of the cation is when that ion's metal atom transfers an electron to the nonmetal, creating a positive ion. Well, an anion, the opposite, the nonmetal, takes the electron from the metal and forms a negative ion. Those two negative and positive ions, being oppositely charged, are attracted to each other. They form a very strong crystal structure that is hard to turn into a liquid or a gas. Okay, that's why ionic compounds have very high melting and boiling points. But that's not all about electronegativity. Bonds themselves can be polar or nonpolar. And to figure out if a bond is polar, you have to look and see if the electrons are shared unevenly between two atoms, creating a bond that has partial poles. Okay, so the difference in electronegativity between the two elements in the bond, say for example H and Cl, would tell us that the electrons are shared unevenly in that particular bond. Okay, the electronegativity difference, that being chlorine being a higher electronegativity than hydrogen, pulls the electrons towards itself because it has a higher effective nuclear charge, creating a polar bond with partial poles. A molecule itself can be polar too. And this is when electrons, the sum of all the bonds around the atom, the molecule, is unevenly shared, and they're uneven asymmetrical distribution of charge. Again, to use the HCl example, since that side of the molecule is pulling all the electrons towards it, the molecule itself is going to basically have a negative end and a positive end. And that's why the sum of all the bonds in the molecule leave an uneven or asymmetrical distribution of those electrons, because chlorine, again, is much more electronegative than hydrogen because of its higher effective nuclear charge. For nonpolar bonds in molecules, you have an even sharing of electrons between the atoms involved. So this would be something along the lines of, H bonded to another H, so molecular hydrogen, H2 gas. Neither one of these is going to win the push-pull for electrons because they both have the same effective nuclear charge, and therefore nobody wins. The molecule itself will not have a favored end, so you have an even distribution of charge. If I can grab this picture and blow it up a little bit, I can't. Oh, it goes away. Sorry, kiddos. I'll make sure that we have Bellworks that cover that very well. So there are no practice pages for you on this packet material. There is a Google Classroom assignment to back it up. There is a POGL that really goes for electronegativity and bond type, though, to help us all out. TTYL.